Hey everyone, welcome back to my channel. Today I plan to show you guys how to toggle a GPIO on a Raspberry Pi using Golang. So the components we're going to need is obviously a Raspberry Pi with Raspbian OS installed, a 100 ohm resistor, an LED, a small breadboard, and two jumper cables. But one side needs to be female and the other side male. So let's wire this up and we can get started on the Go code. Alright guys, before we get to wiring this up, I just want to show you how this small breadboard works. Basically every little row here is a single node, meaning they're all connected to each other. So I have my multimeter set to continuity. So you should hear a beep if it detects a short or a connection. See that? If I go to any hole in that row, it's connected. If I go to the row below, you will not hear a beep because they're not connected with each other. Or the row across from that one. See? So that's pretty much it. Each row is a single node. All right, let's get this thing wired up. All right, so I just wired this up. So I decided to use the last two pins on the Raspberry Pi, which is pin 40 over here for the GPIO, and then pin 39, which is a ground. So connected to the GPIO output is the resistor here, you see it on the same row. So I jump to the next row across, and you can see that the anode of the LED and the resistor in the same node, so it's connected there. And then the cathode of the LED is connected to ground. So just a quick demonstration of this circuit drawn out is like this. GPIO output goes to a 100 ohm resistor to an LED and then grounded. That's it. Let's get coding. All right, so here I have Visual Studio Code opened up and I have a blank main.go file. So let's start development. All right, we want to start with package main. Now we want to import all our packages. Just import, and I'm going to use log for the errors. I'm going to use time for the LED blinking interval. And then these next three are going to be the critical ones to control the hardware on the Raspberry Pi, which is perif.io/x/con/v3/GPIO. And below that we want to type in perif.io again /x/host/v3, and again perif.io/x/host/v3/rpi. All right, now let's start with the main function. So func main, and first thing we want to do is load the drivers, and the way we do that is by running host.init. And this returns something that we're not going to use, so we can just do an underscore, comma, and then it also returns an error. So we can do like that. And then let's make this an if statement. Nil. And then let's do a log.fatal error. All right, next we want to do an infinite loop. But before I do that, I want to run a ticker. A ticker is basically a repeating alarm at a fixed interval, and we'll set that interval here shortly. So new ticker, and then I want the interval to be 500 milliseconds. All right, and then I want to set the GPIO level to set this to high. Now let's start that infinite loop. And we can do that by using a for loop without any conditions. And then now we want to access the GPIO on the Raspberry Pi. And we do that by typing our pi p1 underscore and then the pin number, which was 40 that we used. And remember, guys, that it's pin 40, not the GPIO number. So pin 40 dot out because we're using it as an output. And then we want to set the GPIO level here. And before we move forward, this also returns an error, so we can do that error does not equal nil, and then log dot fatal, and then error. Right here, we want to toggle the GPIO level, so we can do that. Equals nodding GPIO level, and then here we do the channel receive operator for the ticker, and then the channel. And I think that's about it. Yeah, that was about right. So basically what we're doing is we're setting a repeating alarm, and it sends a signal to the channel. And so this is the channel here. And here we're basically blocking until a signal is received. Once it's received, we just continue with the loop. So basically what this is doing is going in, setting it as high, toggling the GPIO level, just the level here, not the actual GPIO. And then we wait for the ticker, which is 500 milliseconds, and then it'll repeat, and it'll continue to repeat. So that's that. All right, so we still have the red squiggly lines here. So let's do go mod init, and I'll name it LED blink. Enter, and then I'll run go mod tidy so I can download and install all the packages that are required. And here the red squiggly lines should go away. And they did, so awesome. Let's clear this. Now we want to compile. So to compile, I'm on a Mac right now, so I need to cross compile. So in order to do that, I need to set some Go environment variables, which is Go OS Linux equals Linux, and then Go Arch for architecture, and it's ARM, and it's Go ARM for the version of ARM, which is 7. And if you don't know your version number, it is, you can just type in on the Raspberry Pi uname -m. Here we can see ARM version 7L, so 7 here. And also be aware that I'm using a 32-bit OS, so if you're using a 64-bit OS from Raspberry Pi, you can just remove the Go ARM and just type in ARM 64, and that's it. But since I'm using a 32-bit OS, I need to add Go ARM version 7. Oops, and then, Go build -o. I want to name the binary LED blink, and then using the main.go file. So let's compile. All right, and that compiled. Right now we want to send this binary over to the Raspberry Pi. So we can do that by running scp. And I didn't change the port number on my Raspberry Pi, but if you did, you can do -p and set the whatever port number you set it to there. But since mine's on port 22, I don't need to add any of that. And then I want to send the LED blink binary, and then I want to use the Raspberry Pi username, and then @ and then the IP address 168.254.28, and then :/ go. You want to send it to your home directory. So / dot, and then hit enter. It'll ask you for your password. Oh, I got it wrong. I'm gonna retype it. And here it's sending. Okay, so it's sent. All right. Now let's go to the my home directory. So cd/home. there's the binary. So let's run it. And you should see, and there we go. There you have it, folks. We have successfully developed a Go application to run on a Raspberry Pi that toggles GPIO. If you like this video, please like and subscribe, and I'll see you guys in the next one.